Well, the questions here, we're doing question 7.2. The question says a company bought office furniture that costs 120,000 rand. After how many years will the furniture depreciate to a value of 41,611.57 according to the reducing balance method, if the rate depreciation is 12.4% per annum? All right. So what we have here is that we are asked to calculate the number of years that will cost the furniture to depreciate. So it's like our unknown, I call it here unknown. Unknown. This is the way I solve words problems. Usually, the first step is to identify the unknown. So we find what we are looking for from the question. Okay, the unknown here is when they say after how many years, so is n the number of the years, so n is the unknown, which is the unknown, and the number of the year. And then I'm going to list the given in the question. You see here, given, the given in the question are what they said. They say a company bought office furniture that costs 120,000. So the principal is the cost of that's the furniture, so 120,000. And then it is also said that after how many years will the furniture depreciate to a value of 41,611.57? Okay, this is the final amount. So this is the amount A, which is given by 41,611.57. Okay, and so okay, and also what else? It is said that according to the balance method, if the rate of depreciation is 12.4% per annum, so the interest here is 12.4%, so which is equivalent to 0.124. Okay, now we can do the calculation. So I'm going to write here formula and calculation. And calculations. Now, what the formula that we connect the given with the unknown? Because we're talking about depreciation, the formula will be given by P equal to 1 minus I all to the power of n. Okay, so A is the amount, which is 41,611.57 equal to the principal 20,000 open bracket 1 minus I all to the power of n. So if I need to find the unknown that I'm looking for is over here, it's an exponent. Now I can get rid of the numbers next to the exponents. Okay, I can divide here by 120, by 120,000, or maybe before I do that, if you used to, because the exponent is because the unknown is an exponent, we can apply the log of logs. Okay, it says this. It says this. We can apply logs formula. It says log of A base B equal to x implies that b to the power of x equal to A. So we can apply this this log formula and move here like this, so we can solve. So in other words, maybe the way I write it, we can see it better if I reverse the order. Okay, we have like 120. We have like 120,000 1 minus I to the power of n equal to I just reverse this order, okay? I prefer to start by 120 equal to 41,611.57, okay? Now, if I want to use my log property, this log property, I can also reverse the order so we can see it clearly. this would be like, it's like b to the power of x equal to a, implies that x equal to log of a base b. So I can just use this property of logs, okay, to work out this. So if I have b to the power of x equal to a, this is equal to, this implies that x is equal to log a base b. So 120, and then 1 minus this, the power of n will be then, I can first get rid of the 120,000. So we have like 1 minus I to the power of n equal to 41,611.5 over 120,000. Okay, to work out n, then I can just use this property above here. Okay, so this means that n will be equal to a log of 41,611.57 over 120,000. Okay, and then if you press this in the calculator, we will get 8 years. Thank you. Oh, someone else can also solve the same problem by doing this. Okay. Someone else can solve the same problem by doing this, because we have 1 minus I to the power of n equal to 41,611.57 all over 120,000. We can introduce the log both sides. Okay, we can put the log over here and then log over there, both sides of the equal sign. So we have like log of 1 minus I to the power of n will be equal to log of 41,611.57 over 120,000. Okay, according to the log property, what we do know is like log of a to the power of b. This is equal to, let's say, I don't want to use b. Let me say n, for instance. Log of a to the power of n is same to say n log of a. Okay, so over here, this means that we have n log of 1 minus I equal to log of 41,611.57 over 120,000. Okay, now to find n, we can divide both sides by log of 1 minus I. So we can just divide this side by log of 1 minus I. We divide that side also by log of 1 minus I. We do that because I know this will cancel out. Our left with n. And if you do this calculation in the calculator, you put in the calculator, you also get 8. Therefore, there will be, it will depreciate after 8 years. Thank you.